Hi everyone! At long last, it's finally time for another update on the Flywheel delayed rifle. I apologize for how extremely long this has taken. This is my final year of working on a mechanical engineering degree, and this semester has been a lot busier than any I'd ever experienced before, so time to make videos and to work on projects in general has been in really short supply. Another reason, though, why this has taken so long is that I had a goal for how much progress I wanted to make before doing another update. The past few Flywheel rifle videos have been 10 to 15 minutes of very similar failures over and over again, and I was really worried that this was getting boring, and I thought that it would be best to be patient and wait for significant forward progress before making another video. The goal that I set for myself was to be able to fire 4 to 5 shots in quick succession without any major damage to the gun. Unfortunately, I didn't end up meeting this goal, but it's been so extremely long since the last video that I decided I owed you guys an update regardless of how much progress was made. So when we last left off, the rifle was having really bad bolt velocity issues due to my hand loads. I was having to compress the powder a lot in order to cram 70 grams into the case, and this was breaking it into really fine grains, which was causing a really fast burn rate. I had also realized that my printed fire control group was a lot farther from working than previously thought, and that I should revert to an AR fire control group. While catting up the next iteration, I came to another decision as well. I decided to switch from 4570 to 450 Bushmaster. I absolutely adore 4570. It's the coolest cartridge out there aside from maybe 577 450, and I was really stubbornly committed to using it. The problem that forced me to consider switching was the availability of trapdoor loads at the time. The market has recovered since then, but at the time I could only find Lever Evolution for sale, which is way too powerful for me to use. The only trapdoor loads that I could manage to find after scouring the entire internet and every gun shop within 60 miles of me was a single box of HSM Cowboy Action loads on Gunbroker for an aneurysm-inducing $80 a box. I really wanted to stick with 4570, but if I did so, the gun would only be marginally less expensive to feed than the Heavy's minigun.
It costs $400,000 to fire this weapon for 12 seconds.
Another factor that drove me to consider switching was an extremely helpful comment that I got from a really cool channel called Dom's Workshop. He's designed and machined a lot of incredibly cool guns from scratch, and I really recommend checking out his channel if you haven't seen it already. He mentioned that he's experienced 4570 cases stretching permanently after being used in semi-auto rifles. I'd been having issues with reloaded cartridges seeming really tight in the chamber, even after full-length resizing. I blamed this on a burr on the chamber face before, but he pointed out that stretching may have been the actual issue. 4570 has very thin case walls, so that's likely the reason why it stretches so much. Interestingly, he found lubrication to be completely necessary for semi-auto operation as well. With these two major problems, that the rifle destroyed cases due to stretching and that new ones were really expensive to buy, I came to the sad realization that switching cartridges was the only way forward for the project. The substitute that I decided on was 450 Bushmaster. It has almost identical momentum to a 4570 trapdoor load, which is super convenient for me, and it's also the most readily available big bore AR cartridge. It's a little expensive at about $1.50 to $2 a round, but that's way better than what I'm used to, so I was happy about that. A nice side benefit of the switch is that I could use AR magazines and magwells. My custom mags mostly worked before, but it's nice to have magazines completely eliminated as a development time sink. 450 Bushmaster is also a closer match to the energy level that I wanted when I began the project. The goal that I had was to work up to more powerful 4570 loads, but the trapdoor loads that I ended up having to settle with were only about 1,500 pound-feet of energy, which is a little disappointing. Getting 2,200 pound-feet for the same amount of momentum thanks to the higher velocity of 450 Bushmaster is really nice. With these decisions about what to change now made, I began modifying my existing design. I grafted a U-bar magwell to the upper and butchered an FGC 9 lower into a new lower to use. The first test seemed really promising at first, and I thought that I'd made a big leap forward. The velocity issue completely disappeared, and the bolt was no longer damaging the backplate at all. It was having some feeding and ejection issues, but I wasn't too worried about that because those are minor problems that I was confident I could fix with some time and lots of tinkering. This brief victory was sadly temporary. I began having issues with the gear splitting in half after just 5 shots or so. This was really depressing because I hadn't really had any major problems with gears breaking before this. I tried fixing this problem by increasing the gear diameter from about 0.6 inches, which is what I'd used on every prototype up until now, to these massive 2-inch gears. This did fix the splitting problem, but now they just started breaking at the teeth. As a final desperate attempt, I changed the module of the teeth to make them as big as I could possibly get them, resulting in these hideous gears. Sadly, even these broke after just a few shots. At this point, I was really tempted to go back to 4570. 18,000 psi trapdoor loads were super gentle on gears. I was actually reusing sets in between prototypes. The actual number of shots that they experienced, though, was only about 30 at most because the prototypes never lasted very long, so I guess it is likely that gear strength would have eventually arisen as a problem if the gun was subjected to actual real-world usage with reasonably high round counts. I eventually came to the sad decision that I really needed to change the material of the gears from PLA to something stronger. PLA was really tantalizingly close to working, but it just wasn't quite enough. Off-the-shelf steel gears and racks from McMaster-Carr were the place that I next looked, but they weren't really an option due to the extremely high price. It would add an impossible-to-swallow $225 to the cost of the build. The solution that I settled on is a laser cutting service called SendCutSend. They can cut gears with an acceptable accuracy for a very low price, and are becoming very common within GunCAD for making metal parts. As a bonus, if I kept the pitch diameter standardized, McMaster-Carr could still be an option for the truly desperate who can't use SendCutSend and are willing to pay the tear-inducing price that off-the-shelf gears command. The only issue is that SendCutSend can only cut soft metals accurately, so I was limited to 1/4-inch 316 stainless. These changes were significant enough that I decided to redesign the rifle from the ground up, which is something I hadn't done before. This new iteration was a lot slimmer and lighter due to the much thinner metal gears. I also switched from an FGC-9 style ejector to a much more simple blade ejector. This time I used a Hoffman magwell instead of a U-bar magwell because the angle I print my uppers at makes the slanted magwell unnecessary. Another change that I utilized is a chain and sprocket to drive the flywheel, which reduces the required gear count to just 2. I lost some time at first due to making my first set of gears way too small, but it was relatively easy to switch to a much more reasonable 1-inch pitch diameter. The test of this prototype was a bit of a mixed bag. On the bright side, the blade ejector worked excellently, and it fed very reliably. There was a minor issue with the charging handle interfering with ejection, but I could easily fix this in the future by moving the ejection port to the opposite side. The sad part is that the prototype destroyed itself after just a few shots. It did last long enough that my friends were able to shoot it, which was really cool, but it got progressively crunchier with each shot due to gear damage as it was fired. One thing that I noticed when I took it apart after the test was that the teeth on the gears were dented forwards, so much of the damage seemed to be happening when the bolt was remeshing during the return to battery. My plan for fixing the rifle was to make the gear system never disengage to avoid this damage happening. My first and second prototypes were actually like this, and they did have ejection issues due to the flywheel sucking up way too much energy and preventing the bolt from moving back more than about 1 inch. I thought that I could probably get this to work this time around, though, because since then I've learned quite a bit about diagnosing and fixing ejection issues, so it seemed like a good solution to try out. So, with what I thought was a solution in hand, I set out to make a new prototype with a permanently connected flywheel. Sadly, it failed on the first shot because of a really dumb design mistake I made. I made about 2 inches of the rack cantilevered because I wanted to make extra space for recoil spring compressed length, and this cantilevered portion bent upwards on the first shot. I then made a new bolt a few days ago with the rack completely supported, and I also lowered the pressure angle of the gears for good measure. Depressingly, even this bolt locked up on the first shot, and when I took it apart I found that the gears had bent like butter. So I've now come to the conclusion that metal gears were a dead end. They perplexingly seem to have less impact resistance than PLA did, and they're super ductile. I could try biting the bullet, selling plasma for a few months, and buying McMaster car gears, but unfortunately the only racks they sell are made from 1018 mild steel. They are 3/4 of an inch wide, which is 3 times wider than what Send Cut Send can do. Maybe that would be enough to make a difference, but the cost is so high that I'm not desperate enough to go down that road yet. So the past year of development has been really disappointing, and I'm basically back where I was a year ago. I refuse to give up just yet, though. My plan for what to do next is to try out nylon gears. Some friends of mine recently got an incredibly cool SLA nylon printer, so I should be able to get some nylon parts relatively soon. Nylon has really great impact strength, so I'm relatively hopeful about this helping. If I still continue to have issues, one more idea that I have is changing calibers once again. 350 Legend is a cartridge that I've been interested in trying out for quite a while now. The main reason why I haven't yet is that it's higher pressure than 450 Bushmaster and has faster burning powder, so I wasn't quite sure if it would really help. But on the other hand, it does have a lot less momentum and a lot less energy, so maybe it would be gentler. It does also have the nice side benefit as well of being really cheap. So thanks for watching, everyone, and a huge thank you to my Patreon supporters for helping to support this project. And a huge thank you as well to the friends who've helped me at every turn. I'm definitely disappointed that Metal Gears turned out to be a complete dead end, but I'm not ready to throw in the towel just yet, and I'm really excited to try out Nylon.